Okay, so open your package to page 35. We're going to start this lesson today, and then you guys will write the quiz. So we are going to continue to use the laws of exponents. So, this will more or less be review to help you for the quiz. The only difference is, Keen. The only difference is, in this case, we're going to be dealing with, exponents that are rational numbers, meaning exponents are fractions. But the rules, the laws of exponents aren't changing. It's just that we're going to be adding and subtracting, multiplying rational numbers, which are fractions. So this is page 35 in your booklet. So we're going to apply the exponent laws to expressions using rational numbers or variables as bases and rational exponents. And then we'll look at solving some problems. So in that first example that's on that page, you're going 9 to the power a half times 9 to the power a half. You're still multiplying powers with the same base. So the law says you add the exponents and keep the base the same. And that's why the 1/2 and the 1/2 are added together. Now you remember, if you have fractions that you're adding or subtracting, you must have the same denominator, a common denominator, which in this case you do. When you add 1/2 and 1/2 together, you add the top numbers, keep the same denominator. This will be 9 to the 2/2. You add the two ones together on top and keep the same denominator. That's how you add fractions once you have a common denominator. And 2 over 2 is 1. That's why it's 9 to the 1, or 9. Okay? So, again, we're not doing anything different than what we did before. Now, you can reverse these statements to get 9 to the 1 is 9 to the half times 9 to the half, or 9 to the 1/2 plus 1/2, or 9 to the half times 9 to the half. So again, that should equal 9. 9 to the half times 9 to the half, we saw above, will equal just 9. The question is why? Well, let's look on our calculator. Let's take the calculator and go 9 to the power 1/2. 1/2 is 1 divided by 2. 9 to the power a half is 3. Brooklyn, what should you not be doing right now? Thank you. So 9 to the power a half is 3. That's why, if we look back up to what I just underlined here, 9 to the half is 3 times the other 9 to the half, which also is 3. 3 times 3 is 9. So that would be a different way to get that answer. The first way we did it was using the laws of exponents. The second way is evaluating each of these separately and then multiplying them together gives you the same answer. The question is, though, why is 9 to the half equal 3? Well, down in part 2, predict the values for 4 to the half. So let's use our calculator to get some of these, and then maybe we can figure out what power a half really means. 4 to the power half is 2. So you might be saying, okay, well, half of 4 is 2. That's true, but the same thing doesn't apply to the previous example where we did 9 to the half. Half of 9 is 4.5, but 9 to the half is 3. So power a half does not mean you're taking half of something. What about 16 to the power a half? 16 to the power 1 divided by 2 is 4. Can anyone have a guess what power a half means? Yeah, that's right. It means square root. The square root of 9 is 3. The square root of 4 is 2. The square root of 16 is a half. So that means that 36 to the power a half should be the square root of 36, which would be 6. So we can check that. 36 to the power a half equals 6. So that works. And the last one there, 49 to the power a half, also equals 7, which is the square root of 49. So we've just confirmed that power a half really means square root. And if you look at, let's write it down below here. I just chose one of them at random. We said 16 to the power a half is the same thing as the square root of 16. Now, when we just have that radical symbol, that's what this symbol is called. It means square root. You can write the power 2 there, but we don't need to. When you just see that radical symbol, that means square root. It's the same on your calculator. If you have that radical symbol, it means square root. Whether you write the 2 or not doesn't change the fact that it's square root. The other thing we can say is this is the same thing as 16, the square root of 16 to the power 1. That is true. 16 to the power 1 is still 16. Why did I write those in there? Well, because when you look at 16 to the power a half, the top number is a 1 and the bottom number is a 2. That means that the bottom number tells you what root it is. The top number tells you what power it's raised to. 16 to the 1 half is the same as the square root of 16 to the power 1. Now, part 3 here says, what do you think 8 to the 1/3 means? Well, if we follow the same pattern as we have below here with the 16, the bottom number tells you what root it is. So because the bottom number is 3, that would mean the cube root of 8 to the power 1. The cube root of 8 is asking what number times itself 3 times will give you 8, and that is 2. And we can do that on our calculator as well. So on my calculator, if I go math and then number 4 in this list is cube root, the cube root of 8 is 2, and 2 to the 1 is still 2. 8 to the power 1/3 should equal 2, and it does. So again, this just confirms what we were talking about prior, and that is when you have any base raised to a rational exponent where the exponent is a fraction, the bottom of the fraction tells you what root it is, the top tells you what power it's raised to. It's not always going to be 1 over a number. It can be 2 over a number or 3 over a number. We're going to see examples like that. But you have to remember that when you have a power, doesn't matter what the base is, if there's a rational exponent, meaning a fraction for an exponent, bottom number tells you what root it is, top number tells you what number it's raised to. So, we're going to be using the same laws that we have before, but now we're going to be dealing with rational exponents. And you may be asked to evaluate, you may just be asked to simplify, which is what we're doing for this first set of examples. Write each product or quotient as a power with a single exponent. Question A, you're multiplying powers with the same base. The law says you add the exponents and keep the base the same. The two exponents are 1/3 and 5/3. They have a common denominator. So that means we can just add the top numbers and keep the same denominator. This will be 5 to the power on top. 1 plus 5 is 6. Keep the same denominator. That's what you do when you add fractions with common denominators. The denominator doesn't change. And 6 divided by 3 is 2. So this becomes 5 squared. In this case, after we simplified, we don't have a rational exponent anymore. We went from fractional exponents to an integer. And 5 squared means 5 times 5, which is 25. So there's the answer. All right, question B. You're multiplying powers with the same base. The law says you add the exponents and keep the base the same. So we're going to have to add 5 or 5 over 1. We're going to have to add that to negative 1 over 2. And in this case, we don't have a common denominator. We need to make the denominators the same. So we're looking for the smallest number that both 1 and 2, those are the denominators, the smallest number that those two denominators divide into evenly, which would be 2. We need to express both of these with denominators of 2. Now the first fraction does not have a denominator of 2. To make this 1 become a 2, we have to multiply the 1 by 2. And if you multiply the bottom by 2, you must also multiply the top by 2. So this will become 10 over 2. That's the same thing as 5 or 5 over 1. Plus negative 1 over 2. Now we can add those fractions together. 10 plus negative 1 is positive 9, and we keep the same denominator. There's your simplified answer, x to the power 9 halves. Okay? Question C. In this case, we're dividing powers with the same base. So the law says we subtract the exponents and keep the base the same. This will be 3 to the negative 3/4 minus 0.25. And in this case, obviously, one of those powers is a fraction. The other is a decimal. Let's see if we can write them in terms of the same form. What is negative 3/4 as a decimal? Well, that will be negative 3 over 4, which is negative 0.75. Because it is a terminating decimal, we can use that. We can say this is 3 to the negative 0.75, take away 0.25. And if you do that on your calculator, you're going to get minus 1. This becomes 3 to the power negative 1. And that's the same as 1 times 3 to the negative 1, or 1 over 3 to the positive 1. There's your answer. So again, in this case, we were able to change the rational exponent, the 3/4, to a decimal, and then work with it like that. Now, question D. As those two stand right now, we cannot use the laws of exponents. Why, Brock? Why can we not use the laws of exponents for question D right now? Can anyone tell me? Yes? The bases are not the same, right? Because the bases are not the same, we can't use the laws of exponents here. However, in this case, I'm going to show you we can make the bases the same, because both 8 and 16 can be written with a base of 2. 8 is 2 cubed. 2 times 2 times 2 is 8. And because the 8 is raised to the power 1.8, the 2 cubed will be as well. And on the bottom, 16 is actually 2 to the 4th. 2 times 2 times 2 times 2 will give you 16. And because the 16 is raised to the 0.3, the 2 to the 4th will be as well. So sometimes you're going to see questions where they don't have the same base, but we can make them have the same base. Sometimes, not always. All right, so to simplify this, we've got one exponent raised to another. We need to multiply the exponents, and the base stays the same. So on top, it'll be 2 to the power 3 times 1.8, which is what? 5.6, I think. Let's just check that. 5.4, sorry. Right, 5.4. And on the bottom, again, you've got one exponent raised to another. 4 times 0.3 will be 1.2. 4 times 0.3. And now we're dividing powers with the same base, so the law says you subtract the exponents and keep the base the same. So it'll be 2 to the power 4.2. And that's how we would leave our answer. Okay? Brock, you need to stay with us here. So on the next page, same thing. Question A. You're multiplying powers with the same base. The law says you add the exponents and keep the base the same. In this case, the exponents are both decimals that we can add together. 1.5 plus 3.5 is positive 5, so that will give us x to the 5th. There's the answer. Question B. What do we do there, Brock? Pardon me? Because you keep putting your head down, and you need to stay with us. Okay? And remember, I talked about this yesterday. You need to copy this stuff down. The reason you need to copy it down is it helps keep you engaged in the lesson. It also gives you something to look back on when you need to find out how to do something, or you're studying for a quiz or a test. The expectation is you copy stuff down. Can you do that? Okay, so that means you need a pen or pencil in your hand. Pardon me? But you won't, though. That's the problem. I don't think you will. If you don't do it now, you probably won't do it. Do you have a pen or pencil? Okay, get it out and start copying this stuff down. Otherwise, I'm just going to send you down to the office because I'm not going to get into a big confrontation about this. Pardon? Okay, you got the first one copied down? Because I already did that one, so you don't have to wait for me. You can start copying that down. Question B. What do we do there, Keen? You're going to add the exponents, and what about the base? It's going to stay the same. So you're going to add negative 5/4 and 1/2. And to add fractions together, we need a common denominator. We don't have a common denominator right now. Our common denominator will be the smallest number that both 4 and 2 divide into evenly. The least common multiple of those two numbers, which would be 4. Both the denominators divide evenly into 4. The first fraction already has a denominator of 4, which means that it's not going to change. It'll stay negative 5/4. But the second fraction, we need to make the denominator 4 by multiplying the 2 on the bottom by 2. That'll give us 4. And if we multiply the bottom by 2, we must also multiply the top by 2. Otherwise, we change the value of that number. Whatever you do to the bottom, you must do the same thing to the top. And now, because we have a common denominator, we can add those together and keep the same denominator. Negative 5 plus 2 is negative 3/4. Are we done, Riley? What do we need to do? Okay, you don't have to yell. I'm standing right here. I can't hear you. I'm sorry. What do we have to do? One more time, sorry. Right, perfect. And remember, this is the same as 1 times p to the negative 3/4. We need something on top. We just can't leave it blank. So that's where that 1 comes in. And when you move from the top to the bottom, the exponent sign becomes positive. All right. What do we do for question C, Declan? And what happens to the base? Stays the same. Now, in this case here, the exponent on top is a fraction. The one on the bottom is a decimal. We can make them the same because if you go 1 divided by 2, it's 0.5. And so essentially, we're dividing something by itself. When you divide something by itself, the answer is 1. That's what you're going to get. Now, if you're not sure about that, well, let's use the laws of exponents. As Declan said, we're going to subtract the exponents and keep the base the same. When you subtract 0.5 from itself, you will get 4 to the power 0. And anything to the power 0 we know equals 1. But, like I said, you could have just said at the start, because you're dividing something by itself, the answer is going to be 1 from that. And you could have stopped and done it that way. It doesn't matter. Okay, question D. What do we need to do there, Allie? What did you say at the start? You're going to have to do what to the exponents? Subtract the exponents and keep the base the same. Do you know what our common denominator will be? Yeah, I've got denominators of 3 and 6. They have to be the same. And the least common multiple of 3 and 6 is 6. That's the smallest number that they both divide into evenly. To make the 3 become a 6, you have to multiply by 2, so you must multiply the top by 2 as well. So that'll become 8 over 6 minus 1 over 6, which is 5 over 6. So the base stays the same. Probably wouldn't be a bad idea to put it in brackets as well, because the power 5, 6 applies to all of the 1.5. Okay, so again, it just asks us to write it as a power with a single exponent. We're not asked to do anything else, so that's what we did. All right, let's look at example 2. Write each expression as a power with single positive exponent, then evaluate where possible. It means get an answer where possible. For question A, everything inside the brackets raised to the power 0.5 outside, including the 4. And then when you raise x cubed to the power 0.5, you probably remember that in that case we need to multiply those exponents. But 4 to the power 0.5 is the same as 4 to the power 1/2. We've already seen that means square root. The square root of 4 is 2. And you can do that in your calculator if you want. If you go 4 to the power 0.5 as a decimal, it'll do it. 0.5 is the same as a half. And we saw on that first page that power half means square root. So this will be 2x to the 1.5. And there's our answer. 3 times 0.5 will give us 1.5. Question B, I'd work inside the big square brackets first. You're multiplying powers with the same base. The law says you add the exponents and keep the base the same. So you're going to add 3, which is 3 over 1. You're going to add that to 3 over 2. To add 3 over 1 and 3 over 2 together, we need a common denominator, and that common denominator will be 2. The second fraction already has a denominator of 2, so the top is going to stay the same. The first fraction, though, we need to multiply the 1 on the bottom by 2, which means you have to multiply the top by 2 as well. And 2 times 3 is 6. So now we can add those fractions together. We have a common denominator. So you add the top. 6 plus 3 is 9. Keep the same denominator. And that's where we are. Inside, when you add the 6 halves and 3 halves together, you'll get 9 halves. Add the top numbers, keep the same denominator. Are we done, Sherry? No, because we have one exponent raised to another. What do we do, Sal? Multiply the exponents and keep the base the same. And when you multiply fractions, you have to remember it's always top times top and bottom times bottom. So on top, 9 times 1 is 9. On the bottom, 2 times 2 is 4. So there's the final simplified answer. Okay? Question C. In this case, the bases are not the same, and you cannot make the bases the same. There's no way you can make 16 with a base of 3. 3 squared is 9. 3 to the power 3 is 27. You're not going to get 16. Okay? So we can't simplify inside the brackets. However, we can raise the exponents inside to the power negative 0.75 outside. The exponent on the 16 on the bottom would be 16 to the 1. So this will become 3 to the 4 times negative 0.75, which I think is negative 3. Let's just check that. 4 times negative 0.75. Yes, that's negative 3. And on the bottom, you're going to get 16 to the 1 times negative 0.75, or negative 0.75. So there's the first step. Now what, Liam? What do we need to do if we have negative exponents, which is what we have? We have negative exponents. You cannot add the exponents because the bases are not the same. Not only that, we're actually dividing here, so if the bases were the same, you would subtract the exponents. Jan, pardon? We're not subtracting the exponents because the bases are not the same. Yes, can't. 16 cannot be expressed with a base of 3. 3 squared is 9, 3 cubed is 27. Yes, you just switch them so that the exponent signs become positive. That's right. You're going to switch the two. The 16 will move to the top and the exponent will become positive. The 3 will move to the bottom and the exponent will become positive. And now we can use our calculator. 16 to the power 0.75. You might be surprised what you get for an answer here. It's an actual number. 16 to the power 0.75 is 8 over 3 cubed, which is 27. There's our final answer. So again, we're going to see why 16 to the power 0.75 equals 8. We will see that as we go through this part of the book. So, on the next page, again, it says simplify and evaluate where possible. Everything inside the bracket needs to be raised to the power 2/3 outside. That'll be 27 to the 2/3. And then when you have x to the 6 to the 2/3, you're going to multiply those exponents. It'll be 6, which is 6 over 1 times 2 over 3. The reason I wrote the 6 as 6 over 1 is because we're going to multiply fractions. And when you multiply fractions, it's top times top, bottom times bottom. So you need a 1 on the bottom of the 6, so you can go bottom times bottom. But we first have 27 to the power 2/3. We can do that on our calculator. And again, you're actually going to get a number, not a decimal, when you do that. 27 to the power 2/3 is exactly 9. This is the reason why. We talked about this at the start of the lesson. When you have something raised to a rational exponent, you can write it as a root, a radical. You have to remember that the bottom, in this case it's a 3, tells you what root it is. So because it's a denominator of 3, that means the cube root of 27. And because the top number is 2, that means it's going to be squared. That's what 27 to the 2/3 means. It means the cube root of 27, which would then be squared. You see, the cube root of 27 is 3, and 3 squared is 9. That's why 27 to the 2/3 equals 9. So this will be 9. And when we deal the x's, it's top times top, bottom times bottom. 6 times 2 is 12 over 1 times 3, which is 3. And 12 divided by 3 is 4. So there's the final answer once it's been simplified. Question B. Inside the bracket, you're multiplying powers with the same base. So Brooklyn, what do we do to the exponents? Yeah, and what happens to the base? Stays the same. So you're going to add 4/3 and 1/3. And in this case, you've got a common denominator there. Both of those fractions have a denominator of 3. So you can add the top number. 4 plus 1 is 5. Keep the same denominator. And that's raised to the power 9, or 9 over 1. And the reason I wrote the 9 as 9 over 1, because now we have one exponent raised to another. The law says you multiply the exponents and keep the base the same. 5 times 9 is 45 over 3 times 1, which is 3. And 45 divided by 3 is 15. There's the final simplified answer, t to the 15. Where's your book, Stanley? Oh, sorry. All right, question C. You cannot make the bases the same. The top has a base of x, the bottom has a base of 64. Can't make those the same. But we've got everything inside the bracket raised to the power negative 2/3 outside. And when you have one exponent raised to another, you multiply the exponents and keep the base the same. So on top, it'll be x to the 3 over 1 times negative 2 over 3. And on the bottom, it'll be 64. This 64 is power 1, so it'll be 1 times negative 2/3. So on top, when you multiply top times top, bottom times bottom, you don't need common denominators to multiply, only adding and subtracting. So it's top times top over bottom times bottom. And on the bottom, we'll have 64, and 1 times negative 2/3 is negative 2/3. Now on top, negative 6 divided by 3 is negative 2, so we can do that, over 64 to the negative 2/3. But now we have to make the negative exponents positive. So Peyton, how do we do that? You switch them, exactly. The x will move to the bottom, the 64 will move to the top. And when you do that, the exponents both change from negatives to positives. You just switch them. Now, 64 to the 2/3. Again, if you do that on your calculator, you're going to get an actual number. 64 to the power 2 over 3 is actually 16. And the reason because is that when you have a rational exponent, you can write it as a radical. The denominator 3 tells you what root it is. The numerator 2 tells you what power it's raised to. And on the bottom, you're just going to have x squared. The cube root of 64 would be 4. And then when you square it, you get that 16. That's where it comes from. So this will be 16 over x squared. There's the final answer. So again, as we've seen, when you have a number raised to a rational exponent, you can use your calculator to figure out what it is, but you also have to know what it actually means. Where is that answer coming from? Okay, let's look at this one. I could go through the work of doing what we just did, making all the negative exponents positive, and get the answer, but I'm going to show you a shortcut, all right? Whenever you have a rational expression is a fraction. We've got 27x cubed on top over 8y to the 1/3 on the bottom. That's a rational expression. Whenever you have a rational expression raised to a negative exponent, negative 2/3, you can make the exponent outside positive by just flipping what's inside. The only sign that will change will be the one on the outside. And again, I could go through all the work doing it the way we just did the previous one. So let's do that really quick. In fact, just watch this. I don't need you to copy this part down. Just watch this. So I'm doing the same thing that I've done on the last couple examples, raising everything inside the bracket to the power negative 2/3 outside. So the 8 is raised to the negative 2/3, and when you have y to the 1/3 to the power negative 2/3, again you multiply the exponents. One power raised to another is done by multiplying them and keeping the base the same. So What I would do right now is I would flip the 27 and the 8. I want those exponents to be positive. So the 8 will come to the top, and that'll be a positive 2/3. The 27 will go to the bottom, and that'll be a positive 2/3. When I multiply the exponents for the x, 3 times negative 2 is negative 6 over 3. Top times top, bottom times bottom. And for the exponent on y, again, it's top times top, bottom times bottom. So now I've got 8 to the 2/3. That is the cube root of 8 squared on top. And x will be to the power negative 2 all over 27 to the 2/3. That's the cube root of 27 squared, y to the negative 2/9. So we can evaluate. The cube root of 8 is 2, and 2 squared is 4. That's going to be on top. On the bottom, the cube root of 27 is 3, and 3 squared is 9. Again, you could get those answers by going in your calculator, 8 to the 2/3 and 27 to the 2/3. You'll get those numbers, but you need to know where they come from. And now I would flip the x and the y. The y would move to the top, the x would move to the bottom. And when you do that, both of those exponent signs change. So there's the answer, doing it the normal way, the long way. But as I said, you also could do this by flipping the rational expression inside the bracket. So move the 8y to the 1/3 to the top, put the 27x cubed on the bottom, and when you do that, the exponent outside will change from a positive to a negative. From a negative to a positive. Whenever you have a rational expression, a fraction of some kind, raised to a negative exponent outside the bracket, if you just flip the fraction, the sign outside the bracket will change from negative to positive. And if I follow this down, I'll get 8 to the 2/3 on top, which is what I have right there. I'm going to have 27 to the 2/3 on the bottom, which again is what I have right there. When I multiply the exponents for the y, it'll be y to the power 1 times 2 over 3 times 3. That gives me y to the 2/9 on top, which matches what I have right there. And on the bottom, when I multiply the exponents, it'll be x to the power 3 over 1 times 2 over 3. That'll give us 6 over 3, or 2. 8 to the 2/3 is a cube root of 8, which is 2. Squared is 4. Y to the 2/9 over 27 to the 2/3 is the cube root of 27, 3. Squared is 9. And I'm going to have x to the power 6 over 3. 6 divided by 3 is 2. So I got the same answer. It took fewer steps. They both work. So again, when you have a rational expression raised to a negative exponent, we can just flip the rational expression, and the exponent outside will change from a negative to a positive. So I have 16q to the 1/3 on top. I'll move the 9p to the 1/2 on the bottom. When I flip that fraction, the power outside the bracket changes from negative to positive. This is our shortcut. I just showed you that it works both ways, but this way is shorter. So now we'll raise everything inside the bracket to the power 3/2 outside, starting with the coefficients. That means the 16 and the 9. And then when we deal with the variables, q to the 1/3 to the power 3/2, we're going to multiply the exponents. Top times top, bottom times bottom. 1 times 3 on top over 3 times 2 on the bottom. For the p, again, you're going to multiply the exponents. 1 times 3 on top over 2 times 2 on the bottom. 16 to the 3/2, that means the square root of 16 cubed. Q to the power 1/2, when you reduce 3 over 6. And on the bottom, 9 to the 3 halves means the square root of 9 cubed. P to the 3/4. The square root of 16 is 4. 4 cubed is 64. And on the bottom, the square root of 9 is 3. 3 cubed is 27. So there's the answer. Again, you can use your calculator to find out what 16 to the 3 halves is. I said it was 64. 16 to the power 3 over 2, 64. So you can use your calculator to check. You need to know why it equals 64, though. You need to know that a rational exponent means you're going to have a radical. That's what the denominator tells you. And that's going to be raised to another power. That's what the top number tells you. Sometimes it's one, sometimes it's another. Okay? Last question before you guys will do your quiz. Food manufacturers use a beneficial bacterium to make yogurt and cheese. The growth of 10,000 bacteria can be modeled using that formula. N, the number of bacteria, is 10,000 times 2 to the power H over 42. N is the number of bacteria after H hours. So H is the number of hours that have gone by. So the first thing, question asks, what does the value 2 in the formula tell you? Well, what it means that the number of bacteria is doubling every so many hours. If that was a 3 instead of a 2, it would mean that the number of bacteria is tripling every so many hours. Okay? We might see somewhere the base is a half. And in that case, it doesn't mean that something is growing, it means that it is decaying or that the bacteria are dying off. And the number of bacteria would be half of what they were every so many hours. But in this case, a base of 2 means the number of bacteria is doubling. So that's my answer for part A. The number of bacteria is doubling. So that's what the 2 means in the formula. How many bacteria are present after 42 hours? So that would be when H is 42. So we would go N equals 10,000 times 2 to the power H over 42. And in this case, H is also 42. How many bacteria are present after 42 hours? That's what H is. It's how many hours have gone by. Now, 42 divided by 42 is 1. So you're going to get 10,000 times 2 to the 1. Or 2 to the 1 is just 2. So that means there'd be 20,000 bacteria after 42 hours. This also tells us that the doubling period for this bacteria is 42 hours. After 42 hours, the number of bacteria doubled. So every 42 hours, it would double. In 42 more hours, there'd be 40,000. And then in 42 more hours, there would be 80,000 bacteria. Okay? Part C. How many more bacteria are present after 2 hours? So in this case, we would let n equal 2 and compare it to what we started with. We started with 10,000. Okay, so after 2 hours, that means h, the number of hours, will be 2. Now, we can simplify that fraction. That power, 2 over 42, is the same as 1 over 21. And we can put this in our calculator. We're going to go 10,000 times 2 to the power 1 over 21. This will give us how many bacteria are present after 2 hours. So I'm going to round that to the nearest bacteria, which would be 10,336. But let's go back and talk about what that power 1 over 21 actually means. We could have rewritten that. Remember that when you have a rational exponent, you can write it as a radical. The denominator, which in this case is 21, tells you the root. So it would be the 21st root of 2. And the numerator, which is 1, tells you what power it's raised to. That's really what 2 to the power 1 over 21 means. It means the 21st root of 2. Now, most calculators will do something like the 21st root. On this calculator, I have to put the 21 in first. I hit my math key, and number 5 in my list is x root. So that'll be the 21st root of 2. If I raise that to the power 1, it's not going to change it. But then it's multiplied by 10,000, the number in front, and I get exactly the same number. Okay? So I used the calculator to find out what 10,000 times 2 to the 1 over 21 is, and then I went back and remember what power 1 over 21 means. It means the 21st root of 2 to the power 1. So the question did ask, though, how many more bacteria are present after 2 hours? How many more bacteria would be the difference between what we have after 2 hours and what we started with? We started with 10,000, so that means there's 336 more bacteria after the 2 hours. Now, part D, how many were present after 105 hours? So N will be 10,000 times 2 to the 105 over 42. And I'm just going to do this in the calculator. You can put it in your calculator all as one statement, and your calculator does order of operations. So 10,000 times 2 to the power 105 over 42, 56,567 approximately. If I round to the nearest bacteria, 56,567. Approximately. And then part E says, how many bacteria were present 4 hours ago? So in this case, because we're going back in time, H will be negative, negative 4 over 42. We want to know how many bacteria were present 4 hours ago, so we're going backwards in time. That means there's going to be less than 10,000 because we're going backwards in time. Now, what does this mean? Well, if we were going to evaluate this, what you might do is realize that you can't have a negative exponent. So you're going to move the 2 from the top to the bottom. And when you do that, the sign will become positive, 4 over 42, which we can reduce to 2 over 21 if we divide top and bottom by 2. So that is one way of looking at it. 10,000 divided by 2 to the power 2 over 21. We said, remember, that the answer is going to be less than 10,000 because we're going back in time, and it is. Now, you actually don't have to do what I just did, move the 2 to the bottom. Your calculator will do it even without moving the 2 to the bottom. 10,000 times 2 to the power negative 2 over 42 gives us exactly, oh, it doesn't. What did I do wrong here? I don't think it's, oh, negative, it should have been negative 4. Is that what you meant? Yeah, thank you. Should have been negative 4 over 42. There we go. Now we got the right answer. 9361. Yep, 9361. Okay, I'm going to put some questions on here that you should work on for practice. But first, you're going to do the quiz. Do the quiz first, and then if you get that done before class is over, you can start working on this assignment. I will post the solutions to this on Google Classroom so you can check your answers.